Newton's third law of motion. This is a very common observation that during the rowing of a boat, a man pushes the water backwards with oars, which makes the boat move forward. Now, ever wondered why this happens? Let's get into the science of it. From the first two laws, we have seen that the acceleration of a body depends on the force acting on it. We have also studied the relation between the force applied and the acceleration produced. Consider a ball initially at rest being rolled down a floor. It hits a wall and immediately starts moving in the opposite direction. Why does this happen? Newton's third law of motion states that if a body A exerts a force on body B, then body B exerts an equal but opposite force on body A. Accordingly, when the ball hits the wall, it exerts a force, say, the action force on the wall. But simultaneously, the wall exerts another force, say, the reaction force on the ball. The reaction force has the same magnitude as that of the action force, but both the forces act in opposite directions. We've already studied in the second law that acceleration produced in any body is inversely proportional to its mass. Hence here, the same amount of force, say F, is acting on the ball and the wall. The mass of the ball is much less compared to that of the wall. The acceleration produced by the reaction force in the ball is appreciable and the ball starts moving in the backward direction. But the mass of the wall is much larger, so the action force produces a negligible acceleration of the ball. Hence the wall does not move. When we walk on the floor, our feet exert a certain force on the floor. But due to the extremely large mass, the floor does not experience a displacement. Simultaneously, the floor exerts a reaction force on our feet and we move forward. Similarly, when a gun is fired, an action force is exerted on the bullet and the bullet moves forward. Likewise, the bullet exerts a reaction force on the gun, due to which the gun recoils. Now, since the gun has a greater mass than the bullet, the acceleration produced in the gun is less. A diver applies a force downwards on the springboard before jumping into the pool. This downward force is the action force. The springboard exerts a reaction force on the diver, and as a result, the diver moves upwards. This helps the diver to take the jump from a greater height. Thus, we have understood Newton's third law of motion, which can be stated as every action has an equal and opposite reaction. Let's summarize. Newton's third law of motion states that every action has an equal and opposite reaction. The reaction force has the same magnitude as that of the action force, but both the forces act in the opposite directions. Newton's third law talks about action and reaction forces, which can be easily demonstrated in a laboratory. We will perform one such experiment.
Keep imbibing. We believe in you.